Tuesday, the 25th, and then for classroom disinfecting, Jalen and Austin, you guys are responsible today. Hi, Ryan.
Yeah.
Okay. Yeah. Find a seat maybe here or there. Yeah, wherever you want. Okay. No, that's fine. All right. So let me show you here on the Moodle page of this class. Okay. So if you miss Wednesday's class, here are the informations on the under the page here, the lecture Zoom link. Okay, office hour link, virtual office hour link, and then course syllabus, homework online platform registration instruction there. So if you missed Wednesday class, there's a video link here. You can click on there and then just go through the lecture over there as well. Basically, what you want to know is for online homework, you need to register through the instruction there, okay? And then it will get you, click on there, there will be instruction on there on how to get registered there. So many of you guys have registered. There's still a few of you haven't, but now it's good time to get registered. Okay, so the first homework assignment is already up there online. I posted on Wednesday. It's due on Tuesday. Okay, so it's about 5 days from now. But this assignment is relatively easy. Okay, I expect you guys can finish the first one like within 1 hour or 2 at most. Okay. All right. What's your name? Clark. Okay. All right. I think I get everyone in class here today. All right. So that's on homework here. And you guys got emails from Kayla for the SI sections already, right? And then she's also doing tutoring one-on-ones as well. Okay. So all right. So I'm going to just put this in presentation mode here. So last time we briefly talked about what's the scopes of physics, what it covers, and then we talk about dimensions. So 4 basic dimensions. Let me hide this guy here. 4 basic dimensions: length, mass, time, and electric current. And most of the other quantities are actually, I think pretty much all of them are derived quantities. That means they are a combination of those 4, okay? But for the first semester, we only deal with the first 3 basic dimensions. We will not talk anything about electric current because that's the topic for semester 2, okay? Another thing I want to mention is, so for any equations you are using, or you come up with a new theory, you say, okay, this theory can be described by a particular equation, for example, Newton's second law, F equal to ma. So it's a good thing to check that the dimension is consistent both sides of the equation. Okay, so for example, on this side equation, it will have a dimension that is the same as the combination of those 2 quantities. Okay, so this is called dimension analysis. Okay, analysis. So for example, if we know force equal to mass times acceleration, and we know the dimension for mass is m, okay, which is in the unit of kilogram, and then acceleration, assuming we know now, it's length divided by time square. Okay, so it will be in SI unit of meters per second square. So in that case, these two should be consistent, okay, on the left-hand side and right-hand side. So you look at the right-hand side, it's mass times acceleration, which means the dimension of mass times length over times square, okay? In SI unit, it's kilogram times meters per second square. So then force should have that dimension, okay? Should have dimension of mass times length divided by time square, okay? And which you will learn later, okay? That's equal to 1 Newton, okay? So force will have an SI unit of Newton, so that means Newton will be equivalent to kilogram times meters over second square, okay? So, but that's something we'll learn in more details later, okay? And again, if you are given an equation, or if you come up with a theory that says one quantity equals to the other quantity plus whatever v times t, okay, that could be, and in the future you'll learn that, or next chapter you'll know that x is usually stands for position, so that should have the dimension of length, okay, it's like certain meters away from the origin. And then x naught is its initial position plus, that also has dimension of length, plus v times t, v will be velocity, you'll learn later again, and then t will be time, okay? So in that case, you'll see that for the x will be in the length of, dimension of length, and then x naught is dimension of length as well, plus, okay, velocity or speed should have a dimension of length divided by time t, okay, and then multiplied by a time t. So this t and this t will cancel out, okay. So you end up on the right hand side, you have length plus length, which will give you length again, okay. It doesn't give you twice of length, but it gives you length. This is something like if you have like $1 plus $1 is $2, okay, in that sense. So it's still in the dimension of dollars or in the units of dollars, okay. So the numbers like 2, 3 doesn't matter, okay, when we're talking about units, okay, it's just in 1 unit. All right. And then I believe there's, I think, one example or one problem here in the first assignment that you guys are going to do dimension analysis, okay? And then also you'll get a chance to do that in one of the labs, okay? Last time we also talked about orders of magnitude, scientific notation, okay, and then prefixes, okay. Now these ones I mentioned, it would be your best interest to remember some of these ones, but the ones highlighted here, I think will be your best interest, okay, to remember them, okay. So if you can memorize them, then you don't have to refer to the table all the time or look it up online, okay. But in case you don't, that's fine too, all right. All right, so, and then there's also, I think also a couple of examples of problems in the first assignment on practice list, okay? So you should be able to figure out that, for example, 241 kilometers, that means 2.41 times 10 to the fifth meter, because kilometer, K means kilo, which is 10 to the third, okay? So if you write in scientific notation, then you move decimals 2 places to the left, that gives you 100, or 10 to the 2, so then you end up with 10 to the fifth, okay? 2.41 times 10 to the fifth, okay? And then also another example here, 1032 picograms, you should be able to write that in scientific notation as well, okay? Because pico is times 10 to the negative 9, all right? And then, all right, I think this is typo. This should be a comma, not a dot, okay? All right. Yeah, looks like, yeah, this is not right here. Sorry about that. I'll correct that later, okay? But you should be able to figure out, okay, how many, but this is the right, okay, this is the right answer over here at the end, okay. So ignore these two numbers for right now because they're not right, okay. So, oh, actually, no, I'm sorry, yeah, pico is 10 to the minus 12, okay, so this is right, I'm sorry. So pico is 10 to the negative 12, okay, then you move 3 decimals to the left, So then 10 to the negative 12 times 1000 gives you 10 to the minus 9. Okay, yeah, this is right, sorry. So then this is 1.032 nanograms, or 1.032 times 10 to the negative 12 kilograms, okay, in that sense. All right, any questions you guys have on this one here? Okay. Last time we also talked about single unit conversion. So when you are doing single unit conversion, you want to know the conversion factor. Okay, so a lot of times it's given to you, or you can look it up online. So for example, this is another example here. If you are converting from feet to meters, then you would need to know the conversion factor from feet to meter or meter to feet. Okay, either way. So 1 meter is equivalent to 3.281 feet. Okay. Then you'll be doing this 360 feet, okay, converting this into meters, multiplied by, now you put the ones that is in feet in the denominator and then meter in the numerator, so that you can cancel out the feet, okay? So then it can give you that quantity in meters, okay, 96.3 in meters, okay? All right. Any questions you guys might have on single unit conversion? That's the last thing we talked about last time. So if not, then we will look at one example on the compound unit conversion. Okay, so for a compound unit, so then your unit is a little bit complicated. Okay, so for example, in this case, it's not just a single unit; it's a combination of 2 units here. So it's meters per second. This is a compound unit. Okay, now how to convert a compound unit into another compound unit? Okay, so we'll start with this one today here. All right. So I'll give you an example on how to do this one, and then I'll ask you guys to try to do the second one here. Okay. So let's do the first one here together. So for the sake, I'll be stop sharing my screen right now, and then use this Ziggy to show the people online that what we are doing here. Class. Okay. All right. So we want to convert the compound unit of 33 meters per second, okay, into, I believe it's, yeah, kilometers per hour. All right, so you are starting with this guy here. Now you want kilometers per hour at the end. Okay, so you want to do this in 2 steps. Okay, so the first one is to cancel out the meter, to convert the meter into kilometers. Okay, and then secondly, you want to convert the seconds into hours. Okay, so let's do this one by one. So the meter, it's on the top here. So then you want to put the meters down here when you are converting it. Okay, and then your target is kilometer, so you want to put kilometer on top. Okay, and if you look up, oh, I think it's probably given here. In 1 kilometers, it's 1,000 meters. Okay, that's 1,000 meters in 1 kilometers. Okay, so in this way, you get rid of meters. All right. Now you still have kilometers over seconds here remaining. Now you want to convert seconds into hours. Okay, so seconds is in the denominator here. You want to put the conversion factor that have seconds on the top here, and then hours are at the bottom here. All right, and then when you look it up, you figure that there's in 1 hour there's 3,600 seconds there. Okay, so there's 60 minutes in 1 hour, and then 60 seconds in each minute. Okay, so that end up with 3,600 seconds. So then you cancel out the seconds there. Okay. So then you'll be doing multiplying the top divided by the bottom, okay? So it will give you 118.8 kilometers per second, per hour, all right? And then if you are wondering how many digits you should be keeping, okay, so it should be this one, but we will talk about the digits later, the significant numbers you want to keep later today, okay? But for right now, I'll just give you that as final answer, okay? You can keep it this way for right now, that's fine, okay? Questions you guys might have on this one, on the first example on compound unit conversion here. Okay, there's a couple chat message here. Okay, I see. That's not related to the lecture here. Okay, got them. All right. So for you guys online, you can always, if you have a slower connection, you can always pull up the PowerPoint slides yourself. Okay. So sometimes when the connection is not good, it kind of appear the screen here kind of appear blur on your end. Okay. So you can always do pulling up the PowerPoint slide by yourself. Okay, on your end. Okay, then it's easier. So type in this short URL, you'll get to the PowerPoint slide. Okay, now I'm going to have you guys try the second one. Okay, and then if you are done, and if you have this PowerPoint slides on your end or computer, for those of you guys online, you can click on the link here. Then you can submit your answers to under that link. Okay, so you guys can go ahead and do that. Guess I'm not sharing my screen to you guys online. Let me do that again. Okay. All right. So for you guys online, you can submit your response to the second question there by clicking the link, clicking on the link. All right. And then I'll be able to see your responses here. Yeah. Unit conversion here. If there's any response comes in, usually will show up on here. All right, I just want to clarify that when you guys are in class, you can also bring your laptop, okay? So you are allowed to use your laptop or your smartphone in the class as well, okay? To submit your responses. And sometimes if you are sitting at the back, you not seeing the screen correctly, you can also pull up the PowerPoint slide on your desk, okay, to see it, to have a better visual on that. All right, let me give you another like 30 seconds or so before we look at the solutions together. Okay, so you can keep submitting your responses online. All right. So let's take a look here together. Okay. It's quite a few responses there. I see most of you guys got the first one right, and then for those you submit the second answers, they also look right to me. Okay, but we will take a quick look here. So the first one, A here, we want to convert from centimeter per second to let me see, to centimeter per minute. Okay. So this is a rather easier one because you just need to convert from let me see, to actually feet per second per minute. Sorry. So to convert to feet per minute. Okay. So again, you want to do it 2 times because there are 2 units here involved. So first one, you want to convert a centimeter into feet. Okay. So if you look at the conversion factor, there's in 1 feet, there's 30.48 centimeter there. Okay. Then you can take care of the centimeter. Now for the second, it's down here. So you put second up there and then minute down here. That's your target. So in 1 minute, there's 60 seconds. Okay. So that way you take care of the seconds there. All right. Now you'll be just plugging those numbers in your calculator. 39.7 times 1 times 60 divided by 30.48, okay, times 1. Okay. Now remember when you are type the numbers in the denominators in the calculator, you want to put parentheses there. Okay. If you're doing that way, then you are doing 30.48 multiplied by 1, then you would need parentheses there. Okay. That's a very common mistake people do because in this case, it doesn't matter because this is 1. Okay. If this is 2, then you'll see you'll get different answers if you don't put parentheses there. Okay. So that give you 17.15 on this one. Okay. So again, for right now, I'm not going to pay attention to how many 6 figures here to keep. Just you can just keep it here, okay? But if you are careful enough, after we talk about the significant numbers, then you'll see that your original number has 3 6 figs. So then you want to keep 3 6 figs for your final answer as well, okay? And for part B, we will do it this quickly, okay, as well. You can start with this one if you are confident with what you get, okay? But it's always safe to start from this one. If this one you didn't get it right, then you will not mess up the second one here, okay? So again, starting from 39.7 over second, here, your target is in miles per hour, okay? So then you want to convert again centimeter to miles and then second to hour. So put centimeter here, put miles on top. So 1 mile, if you look it up, 1609 00. Okay, that take care of the centimeters. Oh, yeah, that's right. All right. Okay. So and then the second here, it's down here. You put second up there. You put hour down here. So in 1 hour again, there's 3600 seconds. Okay. So it'll give you 0.888, okay, miles per hour on this one. Okay. Okay. All right. Any questions you guys might have on this? Yes, clock. Right. So we haven't talking about what six figures to keep, how many six figures to keep yet. Okay. So for right now, it's fine. But after we talk about that shortly, just in a few minutes, we'll touch on that. Okay. Then you want to pay attention to how many figures you are keeping. Okay. All right. There's a couple chat messages here. Let me see. All right. So this is about technical issue. Somebody saying they couldn't find where to submit it online. Okay. So yeah, it's on the PowerPoint link. If you couldn't click on that, you probably want to do Control and click. Okay. And then we'll bring out a new tab. Okay, where to submit it. Okay. So let me know if you still have difficulty on that later on. Okay. So let's see. All right. Now that's unit conversion, single unit conversion, compound unit conversion. Now let's move on to another topic here in this chapter. It talks about accuracy, precision, and then the significant numbers. Okay, so how many numbers you want to keep when you are reporting your measurement or submitting your answers. Okay, so let's touch on that one. Now the first one on the accuracy and precision. Okay, so this is referring to if you are doing a physical measurement. Okay, so for a certain quantity. All right, so you can figure that if you have a very good instrument, then your measurement will be more precise, okay, than if you have an older one, okay? So that's referring to precision. So for example, for some of the digital instruments, you can actually measure, say, up to 4 digits up to the decimal point, okay? For some of them, you can only have 2, okay? So it's clear that for more, if you can have more digits up to decimal point, assuming they are in the same units, okay? So then you have more precision on that one, okay? So that's precision, okay? So like for this one, you probably get 4 digits up to the decimal, okay? And then for the balance machine we have at the back there, you probably don't get as many digits as those ones, okay? So accuracy refers to how accurate you are actually getting to the actual value. Okay, so for example, you are measuring something, say it's 5 centimeters, and then you always get like 4.9, 5.1, or whatever around, just something around that number. Okay, and then you are accurate. Okay. Now, precision sometimes can be misleading because if you are using a instrument, say the actual value for the length of certain object is 5 centimeter, okay? But if you have very advanced tool, you always get, say, 4.555, okay? 3 digits after decimal point, okay? But you are actually off quite a lot, okay? You're always getting something, say, very precise number. If you are doing multiple measurements, your measurement are always close to each other, okay? Within, say, maybe less than 1/10 of a percent, okay? So you are very precise, but you might be off. You might not be accurate, okay? So that's precision. You can be very precise, but you can be not so accurate, okay? So those are two different concepts, okay? Precision means you can be very precise when you're doing your measurement, okay? Now, when that happens, if you're off by some amount, okay? So that usually tells you your measurement is done wrong, okay? Or there's a problem with the tool itself. For example, it's not calibrated well, okay? It's not calibrated to 0 when it's 0. So then that happens. You always get, say, so for example, if you have a digital caliper will, yeah, we probably don't have one here, but say if you have digital balance, okay, it's not calibrated, okay, so then you are always off by say 2 grams, okay. It's measuring 2 grams if it reads 2 when nothing is on it, okay, so then you always are off by 2 grams, okay. All right. When you are doing measurements, okay, there's always uncertainty, meaning you cannot get to very accuracy what's the your readings will not be exactly as what it actually it is, okay, depending on the instrument you are using. So if you are using a ruler, okay, if the least count on the ruler or the least division on the ruler is 1 centimeter, okay, then you always say if you have object, this one, the black one here, it's 2 point something centimeter, right? You are not sure it would be 2.3, it could be 2.4, right? In this case, for some people, you are probably saying, okay, this is 2.3-ish. But for some other people, you probably say this is 2.4, okay? So depending on who are taking the measurement, there's always this uncertainty on the last digit here, okay? But that digit is still significant, right? Because you can say, okay, then this is about 2.3, right? If you don't report that number, some people may be wondering, so this is this 2.0 or 2.9, right? So you still want to report this digit, okay, according to your best estimate, okay? So that one is still significant, okay? So then we still count that as a significant number, okay? Even though it's an uncertain digit, okay? So in this case, you better, the best way to report this is you write down 2 point, this number is according to your best estimation, okay? And then plus minus 0.1, okay, centimeter. So usually you take 1/10 of the least count as your uncertainty, okay? So this is 1/10 of the least count. Least count is 1 centimeter, so 1/10 of it is your uncertainty, or sometimes some people refer to it as error, okay? So 2.3 plus or minus 0.1 centimeter, okay? That's how you want to report, okay? So this is one way to report your actual measurement with uncertainty. There's another way to report is with percent uncertainty, okay? So then in this case, you can write 2.3 plus minus whatever percent, okay, this gives you. So the percent uncertainty should be your uncertainty of 0.1 divided by this measurement number, okay, that you are reporting 2.3. So that looks like giving you something like 4%, 4 to 5%, okay? So you'll be writing 2.3 centimeter plus or minus say 4%, okay? So these are the two ways people are reporting uncertainty, okay, with absolute uncertainty number or percent uncertainty, okay, either way, that's both are fine, okay. All right. I'm not sure if we have connectivity issue. Looks like quite some people dropped offline. Okay, but looks like we are fine on this end. All right. So now let's look on an example. Okay, so imagine if you are in a lab, you are asked to report the circumference of a rod, but all you have is a straight ruler. Okay, so you cannot bend the ruler around the rod there to measure the circumference. But you can do it a different way. You can take the measurement of the diameter, and then given that the diameter, you will be able to calculate your circumference, okay? So circumference equals to pi times your diameter, right? So you take a measurement, it tells you it's 10 centimeter for the diameter, okay? And then this is the ruler that has probably has the list count as 1 centimeter. So you are going to estimate the next digit. It appears like it's exactly falling on the 0, so on the 10 mark. So you say 10.0, okay? Now, because of that uncertainty, that tells you you could easily be off by a tenth of a centimeter. So that means your uncertainty is 0.1 centimeter, okay? So your D, if when you are reporting, let me make this camera review a little bit larger. So for those online, and you guys can see it also a little better here. So you need to report that your diameter is equal to 10 centimeter, right? Plus minus 0.1 centimeter, all right? Your best estimate plus minus the uncertainty, okay? So plus minus means the uncertainty. It could be more or could be less, okay? By that amount. Now, you can calculate what's this guy, okay? When you are calculating this guy, the circumference, you take the 10 into the equation, okay? You don't take this there for right now. You can do it later. So you do pi times 10 centimeter, okay? Which tells you 31.4 centimeter if you do that, okay? But you still want to report your uncertainty, right? To report your uncertainty, again, you do the same here. So your uncertainty, okay, should be equal to pi times 0.1 centimeter, okay, which will give you 0.314 centimeter. That's your uncertainty, okay? So then you need to report that your circumference is equal to 31.4 plus minus 0.3 centimeter, okay? That's how you want to report it. Now, some people says when you are reporting uncertainty, you always want to round up, okay? So you may be hearing somebody say, so because there's other digits after 0.3, so you want to report plus minus 0.4 centimeter, okay? All right, so this is also fine, okay? You can do it this way, you can do it that way, okay? Either way, depends on what are the requirements, okay? You can do it this way. You can also report percent uncertainty. Okay, so because this guy is 0.1, so if you look at percent uncertainty, then it's 0.1 over 10, right? And then multiply by 100%. Okay, so you guys may encounter this a lot. When you are doing percent uncertainty, you want to do uncertainty over the measure value times 100%. Okay, so that will be 1%. Okay. So you can report as this way, or you can report as your circumference equals to 31.4 centimeter plus minus 1%, okay? So both ways are fine, okay? Either that one or that one. So you can see this way, it might be better for you to report percent uncertainty because then you don't have to deal with considering you want to keep this one or that one, okay? Because some people are very particular about how this need to be kept, okay? So, and I agree more on this side. You want to report 0.4, okay? Because that gives you more range to cover your possibility of being underestimated, okay? Yeah, but anyway, we don't have to worry about this so much in this class, okay? Either this one or that one, okay? So either way will be fine with me. All right, any questions you guys might have? So, and then let me see if there's any questions on in the chat. No, it's clear. Okay. All right. Now we are getting to the numbers part, okay? Like how many numbers we should be keeping when we are reporting, or how many digits we should be keeping when we are writing our answers down, okay? There are quite a few types of numbers in this class. So exact numbers, say we have 12 of you guys here today, so 12 is exact, okay? We don't have like 12.1 of you guys here, it's just 12, okay? Now, some mathematical constants, that's another types of numbers, it might have a lot of digits afterward, okay? Or some other numbers, say, whatever you guys will encounter later on, yeah, say, I think most of them appears next semester. For example, gas constants, Avogadro's numbers, those types, okay? And then electric constant, dielectric constant, etc. So those are particular numbers as well, okay? So that's the second type. Now, a lot of them will be measurement numbers, okay? So for example, diameters of something, that's 1.563 plus minus 0.002 meters, okay? Another quantities will involve in calculations. Okay, so for example, the example we look when you are calculating for circumference. Now you don't have direct measurement of circumference itself, but you want to utilize a equation to calculate for it. Okay, this is the last type. Okay, so 4 types here. All right. Now the question comes, how many digits do we keep? Okay, or how do we write this different numbers? Okay, so for exact numbers, integers, you just put the integer numbers. Okay, so for example, for marbles, there's no uncertainty on there, certain. Mathematical numbers, okay, depends on the other numbers involved in a particular problem. Okay, so I think for your calculator, if you are just typing pi, then it takes care of it. Okay, so you don't have to worry about it if you are using your calculators. But if you are not, then for example, in the problem, you are sure you need to report 3 digits at the end, then you can keep 4 digits here for this number. Okay, so just always keep 1 extra digits as necessary. Okay, and also for mathematical constants, okay, they don't count to the significant number. So for some mathematical constant, it's having just say 1 digit or 2 digits. So some mathematical number maybe just like 2. Okay, then it doesn't count when you are counting how many 6 figures. That constant number doesn't play a role there. Okay, you have to look for the significant numbers from the other numbers in the problem. Okay. Physical measurements, okay, then you need to keep up to the uncertainty digit. Okay, so this is uncertainty digit. Okay, so those 3 numbers are exact numbers, right? You are sure it's 1.56, and then 3 is your estimation. It could be 4, could be 5, could be 2, could be 1. Okay, because uncertainty is 0.002. Okay, so it has a range from 1.561 to 1.565. Okay, so the large digit is not certain, but it's still significant. Okay, so it counts as 1 significant number there. So you have 4 significant number there. All right, and then in general, that digit is least certain. Okay, it's not certain. The other ones are certain. All right, so I think we covered the last item there as well on this one. All right. So rules when you are working with 6-figure numbers, okay? So for example, if someone gives you a number, say 444, so then by default, you are assuming that he knows it's a 3 6-figure number, okay? Because he gives you 3 digits there. And then another number is 2.2. So this one has 2 6 figures, okay? 2 significant figures. Thanks, sorry for those of you guys online. Maybe better for me to put the camera on the screen. give you some sense what I'm talking about, okay? So 2.2 has 2 sig figures, 444 has 3, okay? So when you do multiplications or division of these two numbers, okay, the rule is to keep the least or smallest number of significant numbers, okay? So that means at the end, you are reporting your answers in 2 sig figs, okay? So then you are doing 444 times 2.2, okay? That will give you 976.8, okay? But you just need to keep 2 sig figs. So you are writing 980, okay? And then we'll talk about, or better, you are writing 9.8 times 10 to the second, okay? So that's when you are doing multiplication or division, you keep the smallest numbers of sig figures involved, okay? So that's the rule. But when you are adding or subtracting numbers, then no more beyond the first least significant decimal place present, okay? So for example, if you are doing plus addition of these three numbers, it could be subtraction, okay? So 1.36, so this is the second decimal point. This is the third one, but this is the first one. So this is the least, okay, significant after the decimal point, okay? Or the one closest to the decimal point, you can put it that way, okay? So you only need to report one digit after decimal point in this case. You add those three up, your calculator is going to tell you it's going to be 12.183, okay? You only need to keep up to the first digit after the decimal point, so 12.2, okay? You still want to round up or round down depending on what's the number after the first decimal place, okay? So it's 183, so that means you are reporting 0.2, okay? Let me put the camera on my paper here for you guys to online to see this, okay? So when you are doing this guy, multiplication 976.8, you only need 2 sig figures, so 9.980. This one, the zero after all the trailing zero, it doesn't count. Okay, we'll talk about it later. Or you can keep this one. Now this is just the 10 to the 2, just the scientific notation. It doesn't count a significant number as well, so 9.8 means 2 digits, okay? On this one, 12.183, you round it up, okay, so it's 12.2, okay? Additional rules here at the bottom of slides here. So let me start with, this is complicated. I always have to switch camera. Let me start with the zeros here, okay? So the zeros, yeah, the zeros to the right of decimal points can be significant numbers, okay? So here, if you are writing this in on purpose, 1.80, so you keep this 0, so that means this is significant, okay? You are reporting it, okay? Times 10 to the third, okay? So this scientific notation just tells you the order of magnitude. It doesn't count into the significant numbers, okay? Just look at this number. So 3 sig figs here. The zeros to the right of the decimal point can be just placeholders, okay? So for example, if there's zeros on this one here, there's nothing else there, then these are placeholders, okay? So these ones do not count as significant numbers, but 1, 5, 6 there. So 3 sig figs, okay? And then scientific notations, okay? So this notation doesn't count, so just 3 there, all right? Now, on this one here, if you see trailing zeros here, now this is ambiguous, okay? So because we are not sure if it's intended as 1.800 times 10 to the 3, okay? or 1.80 times 10 to the 3, or 1.8, okay? So it could be this could mean these two are significant, or 3 or 4, all of them are significant. If you want to be very precise, you want to use scientific notation here, okay? If you know this is two 6 figures, then you want to write 1.8 times 10 to the 3, okay? If you want to indicate it's 3 6 figure, you want to put 1.80 times 10 to the 3, okay? If you know this is also significant, then you want to put 1.800 times 10 to the 3, okay? To use scientific notation that way. All right. Let's have a look at some more examples here. So on this one, those three numbers, okay? So let's take a look. The first one here, because it's 0 before the decimal point, okay? So then these 3 zeros, they are just placeholders, okay? So they don't count as significant numbers. But now these 3, you know, they are non-zero numbers, they are significant numbers, but there's another 0 afterward, okay? So the zeros, the rightmost zeros after decimal points count, okay? So then in this case, you will count 1, 2, 3, 4. It's 4 6 figure on the first one, okay? And are we clear on this one? All right. Now the second one here, because this is non-zero, okay? So then the zeros just right after the decimal point, they also count, okay? So you'll count 1, 2, 3, 4, 5, and then this is trailing zeros, rightmost 0 after decimal point, they also count, okay? So the second one, it's six figures, okay? So all digits count. This is 6 significant digits, okay? Now the last one here, again, if you are writing that way, then people will interpret it as it could be 2 6 figure, it could be 3, it could be 4, okay? So this one is ambiguous, okay? Could be 2, could be 3, could be 4, okay? So then again, the best way to do is to write into scientific notation if you know how many 6 figures are in that number, okay? Now, for who are measuring it, that's the person should know how many 6 figures, okay? So whenever you are reporting, it's there are zeros, at the end, you want to write in significant numbers, okay? All right, another rule of thumb here, okay, rounding off errors. Because sometimes when you are doing calculations, so for example, if you figure for this particular problem, you want to keep 3 6 figures at the end, right? So it's your best interest to keep extra digits during your calculation, okay? And then at the end, you round it to the correct number or significant numbers, okay? So for example, during the calculation, you can always keep 4 6 figures, and then at the end, you'll just keep the 3 6 figures, okay? All right. You can keep one extra 6 figure, that should be enough, okay? But if you want to keep more 6 figures during the process of the calculation, then you'll be fine as well, okay? So that's another rule from rounding errors, okay? Because if you are doing it differently, all right, sometimes if you keep 3 6 figures, then at the end you get this number, okay? But if you are keeping more 6 figures, you will get another number, a little bit different, okay? Not too much, but slightly different. All right. The end of this chapter talks about approximations, okay? So sometimes it's better to use your common sense to give an approximation what the final answer should be, okay? So for example, if there's a tall building, and you can do an estimation of what number it could be or how high it could be. Then if you are doing some calculation, if your calculation are far away from your approximation or your estimation, then you should check your calculation again, okay? So you guys can look through that section by yourself. Okay, it gives you a basic idea how to judge if your final answer makes sense or not. Okay. So any questions before we finish today's lecture? Yes. Mm-hmm. All right. So yeah, so you are not here last time. So your question is for the textbook. It's open source from OpenStax. You can go there, click on the subject you want to download the college of physics. Okay. OpenStax. It's in the syllabus, but it's in OpenStax.org. Okay. College of physics. Okay. You can get a free download of it, or you can, if you prefer paperback, you can buy it on Amazon. Okay. And then we don't have lab this week. Okay. Lab starts for next week. All right. Yeah. And then you should check the lecture video last time to see all the details about other things. Okay. You can also email me if you have other questions. All right. All right. Clock. Yes. This one. Yeah. So B will be 6. Because it's non-zero numbers before the decimal point, so these 2 zeros count. But this is the trailing zeros after decimal point, you also count. Okay, so okay, all right. So that's all for today. See you guys on Monday. So on Monday we all are online. Okay, so you guys don't have to come here on Monday. Okay, but you can still come here. I think this will be free. If you don't find a place, you can stay here. Just do the lecture online. Okay. Everything is on Moodle. Yeah. Yep. That's fine. Sure. Yeah, no problem. That happens. Yeah. Thank you. Yeah. Just wipe down the surface of the desk and then the armrests should be enough. You too. Thank you.